Okay, so I want to start looking at 1.6. I had planned to do all of 1.6 today, and that would put us on track for test on Friday. However, it's looking like I'm going to have to finish up some 1.6 tomorrow, just because of checking the workbook pages. It takes a little bit longer than the Math Excel type assignment, so we're going to start 1.6. I would encourage you to start the workbook page. However, it's not looking like it'll be due tomorrow. I'll plan to finish notes tomorrow, and maybe with any luck, we can have some work time tomorrow to be finishing up that 1.6. Okay? Lesson 1.6 is absolute value equations and inequalities. Again, review stuff. You've seen absolute value equations and inequalities. However, with that said, I will also tell you this is the first actual Algebra 2 standard we're covering this year. Okay, the other stuff we've been doing technically falls into Algebra 1 review. It doesn't really fall into specific Algebra 2 standards, but this one does. So, absolute value. What comes to mind for absolute value? Nothing? What if we take the absolute value of a number? What do you think there? Okay, so if it's a negative, it's going to make it positive. What if it's already positive? It stays positive, right? So absolute value, generally speaking, makes a value positive. Okay, now if we think definition-wise, absolute value of a number is the distance. Do you remember this definition? The distance from the number to 0 on the number line. That's the definition of absolute value. And that's the reason that absolute value is usually positive, because distance can't be negative. Doesn't matter if you're going left, right, forwards, backwards, distance can't be negative. And so a number is a distance, or absolute value of a number is the distance a number is from 0 on the number line. Thus, since distance is always positive, absolute value of numbers will be positive. We're also going to talk about extraneous solutions today. Okay, extraneous solutions, it's a big word, but it's extra solutions. Those are the solutions that we might come up with two answers, and with absolute value, often both answers will work, but there are specific situations I'll talk about where both answers don't necessarily work. And so those are extraneous solutions. So extra solutions that, yeah, they came up, but because of the absolute value, they might not make the statement true. And finally, absolute value needs to be isolated to solve these types of equations and inequalities. So as we go through class today, I'm hoping you'll get tired of me asking the same two questions all period long. That's my hope, because that means it's like kind of stuck in your head. But the first question I'll be asking every problem, is the absolute value isolated? Okay? And once it is isolated, so once you have that absolute value by itself, all the other outside stuff away, then I will talk about setting up not one, but two equations or inequalities. So we'll isolate the absolute value. Then we will set up two equations or inequalities depending on the problem. So, with those comments in mind, let's work on example A. Absolute value of 2x minus 1 equals 5. You're being asked what is the solution to each equation, and it says the graph the solution. So we will talk about what the graph looks on this first one. Okay, my first question to you, every problem today. Is the absolute value isolated? So is my absolute value by itself? Yeah, on the left side, I have absolute value of 2x minus 1. There's stuff inside the absolute value bars, but nothing outside. So yes, absolute value is isolated. So once the absolute value is isolated, what am I going to tell you? Need to set up 2, right? 2 equations or inequalities. In this case, equations. Do we have to remember what these equations look like or are? The first one's easy. What's the first equation we're going to set up? The given equation. So first equation is always the given equation. Just drop off absolute value. So 2x minus 1 equals 5. That's one equation. Or, anyone remember what we changed to get the second equation? What do you remember, Sarah? Try it. What? No, we're not changing the minus to a plus. We actually change what's not inside the absolute value. So whatever's inside that absolute value actually stays the same every time. So it's going to stay 2x minus 1, but instead of equaling positive 5, it's going to equal negative 5. So our second equation is going to be 2x minus 1 equals negative 5. Okay, so always the same. The first equation, you write it as is. Don't change anything. The second equation, we keep whatever's in the absolute value bars. We do the opposite signs on the other side. So now we have the equations 2x minus 1 equals 5. 2x minus 1 equals negative 5. Okay. If it's 2x minus 1 equals 5, what do I do to solve? Add 1. We add 1 on the left. Add 1 on the right, and 2x equals 6. What's next? Divide by 2. We divide by 2, x equals 3. Or, and I always just put the word or here because my answer could be either or. 2x minus 1 equals negative 5. Again, we need to add 1. Minus 1 plus 1 cancels. 2x equals, what's negative 5 plus 1? Negative 4. How do I get x by itself? Divide by 2 and x equals negative 2. And you just came up with 2 answers. Okay, notice it's not just necessarily, the same answer. It's not like, oh, there's 3 and so negative 3 is my other answer. Notice they came up different numbers there. Now, officially, this section says to graph. I'm not a huge proponent of graphing these, but we're going to at least talk about the graph on the first one. How do I graph the solutions x equals 3 and x equals negative 2? Any thoughts? But are there less than and greater than signs? What? Okay. But are we going to shade? We're not going to make shady. What are we going to put? Okay. We actually can't. Okay, so I didn't talk about checking. Actually, both of these answers do work. And here's the deal. Because, so the question is, well, does this negative even work? And look at what's happening here. It's not just saying the absolute value of that number. If I put in x here, actually it doesn't, if I put in x here, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. But then it says absolute value, right? So actually, my answers could be positive or negative. Okay, so they are both valid answers here. You can do the same thing for 3. If you put it in, 2 times 3 is 6, minus 1 is 5, absolute value of 5 equals 5. Okay? Now, with that in mind, though, the graph. This is just x equals 3. It's not less than 3, it's not greater than 3. And it's x equals negative 2. It's not less than or greater than. So where is x equals 3? It's at what? It's at 3. Okay, so we're going to put a dot at 3. Now, was it Luke? Did I hear you say something about we don't know what kind of dot? It equals 3. And it equals negative 2. So that's like a closed dot. It's just a regular filled-in dot. If you're going to put an open dot there, that means that nothing exists there. But since it equals 3, we put a filled-in dot. So I'm going to do a quick number line here. So since it says x equals 3, that means officially I put a dot at x equals 3, or a point. Since it says x equals negative 2, I'm going to put a point there. And when it's just x equals a number, that's all you do to graph. Okay? I reviewed it because we'd forgotten, right? We kind of forget. How do you just graph a dot? You guys probably could have graphed a less than or greater than easier than the dot. So that's why I review it, but we don't do a whole lot with it. Probably part of the reason we've forgotten it. Okay. You ready for B? Okay. See if you can remember the beginning. What's my first question? Okay, good. Is the absolute value isolated? Yes, it is. So, step 2, if absolute value is isolated, set up 2. So we're going to set up into 2. One of them is going to be the given positive, 3x plus 2 equals 4. Or, what's going to change on the other one? Positive 4 becomes negative 4. Whatever's in the absolute value stays as is. You just change what's outside the absolute value. And can we solve from there? Solving is not my huge concern today. It's how do we get set up and all of that. So if it's 3x plus 2, I'm going to subtract 2. 3x equals 2. How do I solve for x? Divide by 3, and x is 2/3. Leave it as 2/3. Don't reach for the calculator. 2 divided by 3 is 2/3. Or, repeat the process. If it's 3x plus 2, again I want to subtract 2. Okay, 3x equals negative 4 minus 2, which is negative 6. Whoops. I jumped down a line I didn't want to do there. And then what? Yeah, divide by 3. Negative 6 divided by 3 is negative 2. Okay. I'm not going to worry about graphing that. We got the basics here, right? Okay, what changes up in section 2? Okay, good. The absolute value is not isolated. So my first question, where you guys have been answering yes, all of a sudden you have to answer no, and we have to take steps to fix that. So, 3 times the absolute value of x plus 2 minus 1 equals 8. Is the absolute value isolated? No. I have a times 3 and a minus 1 hanging around. What do I do? What'd you say, Jess? I can't do 3 minus 1 because this 3 is multiplying by the absolute value and this minus 1 is being subtracted. We're not going to distribute. I mean, I guess technically you could distribute, but usually I teach that we just leave the absolute value by itself.
Did you get rid of the 1 first?
And how would we get rid of the 1? Yeah, okay. Think of this like, if this is 3 times, it's times absolute value, times A. So think of this, if this was 3A minus 1 equals 8. If it was 3A minus 1, what would you move first? The minus 1. You would add 1, yes? And that's exactly what we're going to do here. So treat it just like you would an equation. So now, 3 times the absolute value of x plus 2, minus 1 plus 1 cancels, and 8 plus 1 is 9. Is my absolute value by itself? Not quite. It's 3 times the absolute value. So how do I do that? Divide by 3. Since it's 3 times the absolute value, divide by 3. If I divide the left by 3, divide the right by 3. On the left, guess what the 3's are going to do? They're going to cancel. I have absolute value of x plus 2 equals 9 divided by 3, which is 3. Okay. So my question still stands. Is the absolute value isolated? Now we're ready to say yes. So once you get that absolute value isolated, what did we talk about doing? Set up 2, right? 2 equations in this case. What's the first equation? Okay, the given at this point. X plus 2 equals 3. Or, what's my second equation? X plus 2 equals negative 3. You keep what's in the absolute value. You just change the signs on the other side. So x plus 2 equals negative 3. Okay. How do I solve for x? If it's x plus 2, we're going to subtract 2. X equals 1 or x equals negative 5. So we have solutions of 1 and negative 5. Okay. So, B. Let's practice again. What's my first question? Is the absolute value isolated? No. I need that x plus 9 absolute value to be by itself. So right now it's 2 times the absolute value and then plus 3. What do I move first? Let's move the 3. Since it's plus 3, subtract 3. 2, absolute value of x plus 9. 3's cancel, so I have equals 4. Now what? Okay, it's 2 times the absolute value. So divide by 2. We divide one side by 2. We divide the other side by 2. What happens? 2's cancel. Absolute value of x plus 9 equals 4 divided by 2 is 2. Am I done? No. Is absolute value isolated? Yes. So now I set up 2. The first one is the given, x plus 9 equals 2. What's the second one? X plus 9 equals negative 2. And if these are x plus 9s, what did you do to solve? Subtract the 9.
Funny interruption, can I have your attention for a few minutes
X
of the
equals?
announcement? We need to see the following students in the high school office. Colby Cross, Jonathan DeWeese, Emily Partlow, Kenzie Eller, John Jimenez Vasquez, Emma Piskey, Wyatt Host, Quentin Schaefer. Please come to the high school office. Students, reminder, be washing your hands before lunch. Seniors, make sure you're checking your emails for scholarship information and deadlines. Athletics tonight, we have boys soccer at home against Taylor at 5. Good luck to the boys soccer team. And we have volleyball at Frankton with the birthday coach at 6 o'clock. Good luck to the volleyball team. Just a quick reminder that there are no backpacks in the classroom. Make sure you're just using a drawstring bag. Thank you. Have a great evening.
Okay, guys. I had hoped to get through one more because my other classes got through one more. But I'm not going to go through any more. But what I will just mention, notice what's different in the next section. Okay, so the directions ask us to check for extraneous solutions. And as you look at the setup of these problems, there's still a variable in the absolute value, but there's also a variable outside of the absolute value. Okay, and that's when you're going to want to be checking for extraneous solutions. So if you go ahead and get started on homework tonight, when you hit the extraneous solution section, don't worry about those. We'll talk about those tomorrow.
I also need Lexi Stanley in the high school office, also cheerleaders and football players. You may purchase tickets pre-sale tomorrow. After that, it's going to the public. Thank you.
Okay, so we'll talk about that tomorrow. Inequalities. We have to talk about how to know when to do an and statement versus when to do an or statement, which is the other reason I didn't want to rush through it. So we'll talk about that tomorrow. 1-6 will not be due till Thursday at this point. Okay? Questions?